Welcome to this video on 12.2. It's about hypothesis tests for one sample population proportions. To review back when we were doing confidence intervals and other hypothesis tests, you need your simple random sample or random assignment in experiment. You have to check for normality and independence, and we'll review how you do all of that for proportions versus means. All right, so the Z, we're always using Z-test for one proportions or one proportion Z-test. The notation is what I want you to focus on right now is notice that the Z, I'll write out again. So you have P hat, so that's your sample proportion from your sample. And then every other P is the null hypothesis P value. So you got the null P in the numerator, and then the standard deviation, you're going to use your null P because that's the population we assume until we prove otherwise. And the below is the same thing that the book was showing with the t-test. Your calculator will do this for you, but all it's saying is if you're one-tailed, which side you're looking for the area under the curve, and if you're not equals, it's both tails, and they're going to be symmetric, so you can just find one and double it. All right, so in the calculator, you're going to need a few things to be able to put in to make it run the analysis. You're going to have your hypothesize value, your null hypothesis proportion value, then your X value, that's the number of successes count. This can't be a decimal. So remember, it has to be an integer. And if you have to calculate the number of successes because you're given the proportion, like let's say you were told your p hat is 0.21 and you know your sample size is, I don't know, 52. If that came out to a decimal when you multiply them together, you just round to the nearest whole integer when you're trying to figure out your number of successes. And then you just have to figure out if you're less than, greater than, or not equal to. All right, so let's just do an example so you can see how this works. We have a quick service restaurant magazine drive-through study involved 7,594 random visits to the restaurants in the 25 largest fast food chains in all 50 states. Approximately 89% of the orders were filled accurately. For those that visit Chick-fil-A, 182 of the 196 orders were filled accurately. We want to test to a significance level of 5%, whether the proportion of all orders filled at Chick-fil-A is greater than the national average. All right, so our null hypothesis is going to be this 0.89 because that's all fast food chains. And then our p hat is going to be the 182 over 196. So this is also, that's your X and that's your N for your Chick-fil-A values. This value here, the 7,000, that's so when you do the 10 times N has to be less than the population, you can compare it to the population and you will be less than that. All right, so let's go through the hypothesis test. Now this PowerPoint is set up with a different acronym, but you can still just use HCCI. There's an acronym some people use called Phantom, but I feel like it's too many letters. HCCI encompasses everything and it's easy to remember. So first we're going to say what our parameter is, which is the P, not the P hat, because we're talking about population proportion. So it's the true proportion of drive-through orders filled accurately at Chick-fil-A. And just like with mean hypothesis statements, the null and alternative are written in terms of the population, not the statistic. So the parameter, not the statistic, therefore you always have P, not P hat in your hypothesis statement. Then we do our assumptions. Our selection was randomly selected it was stated in the question. Independence, Oh, because we are checking for just Chick-fil-A, so it's actually not compared to that 7,000 number. We have to assume more than 1,960 Chick-fil-A restaurants. Apparently, when I Googled, last I checked, there were over 2,200. There's probably a larger number now. And then for normality, the NP check, you can use the null hypothesis for the p-value there. So 0.89 and then 1 minus p is 0.11. And both are at least 10. So we can say that due to the central limit theorem, our sampling distribution is approximately normal. All right. Then if you haven't named the test already, you want to name the test. So it's a one sample z-test for proportions. You want to make sure you say for proportions because we have z-test for means. And then if we put in our values, we got 0.929 is the proportion from the question where it was 182 over 196. And you do all that out, you get 1.726. And then we get the p-value from the calculator, and it comes out to 0.042, which is less than alpha. So we can say, since the p-value is less than the alpha value, I will reject the null. And there is statistically significant evidence that the Chick-fil-A drive-throughs fills their orders correctly, greater than the national average. All right, so that's the example. That's all there is to it. But I just want to show you the calculator. So let me jot down the key numbers. And we are doing greater than, okay. All right, so one prop z-test, we want to do 0.89. Our success was 182 out of 196. We are greater than, and we calculate, and there we get our z. We get our z value, our p value, and then the p hat, that's the 182 over 196 for you. So it calculates that as well. So before you show your work, you can actually just run this so you get all the calculations out for you. And then when you're substituting in to the z formula here, just to show your work, you have the p hat value and then the null p as well there. And then you get the p all by itself is the p value, which is assuming the null is true, what's the probability of getting the sample? And it's only 4%. So we say that the null is probably not true, and therefore we reject the null. All right. So that's the only difference for running a one proportion z-test. And it really is, the biggest difference is the formula here. So I'm going to write it one more time for you. So it is the sample proportion minus the null proportion all over the null times 1 minus the null all over n. So that's your z value. Because the hardest part with the proportions is figuring out which p proportion value to use, your sample or the null. The sample only shows up in the one spot at the very beginning of the z-score. All right, so I will see you in class where we will practice this along with the t-test for means.